In this video, I'm going to explain you about the class classification using the machine learning techniques such as ID3, CART, and ID3, CART, and the neural networks in the random forest and logistic regression, etc. So to do this, first we have to pick the dataset, right? This class classification dataset is picked from the kaggle.com, which is mentioned in the video description. You can find it there. So after that, let's go in detail with the dataset. So this dataset mainly contains of the columns, that is the 9 columns which represent the chemicals, and the first column is ID number, which is included in the CSV file as mentioned there. And after that, the type of class is what we have to predict, and it contains total 7 types of class. We are predicting these 7 types of class based on these chemicals. So let's go to the code and let's complete this thing. So from here, the import pandas and numpy are used to import the dataset. So we are importing the dataset, the class.csv, as using the pd.readcsv function. So as the readcsv function is used, we are importing the data and this executed. Okay, now it's good. After this, let's go. Now we are assigning the last data, the last column as a target data, as the target column. So to do this, y is taken as df of type, and this column is stored as y and y dot head of. So let's do that. After that, we are dropping the last column, which is not to be called calculated, right? That is the df dot drop type and examine. So we can directly drop the last column, that is which we have to predict thing that is not required. So after that, we're going for that. After that, now as the all data points are in numeric format, we don't have to differentiate the columns like one hot encoding. This all can be neglected. We can directly proceed to the normalization. So in order to process the normalization, we are importing the pre-processing from the sklearn, and using the min-max scaler we are doing this. Min-max scaler is equals to pre-processing min-max scaler. This is initialized here. After initialization, we are just passing the parameter, that is the x, df dot values. From each value it passed as the parameters to the x, and min max is calculated, and all these are arranged between ones and zeros. After this is done, pd dot data frame shows as data frame, and then df gives the output of it. You can see here that all those values are between ones and converted as ones and zeros. After this is done, this is what is done. We can run this out. Okay, after doing this, we got this. After normalization, now we have to split the data for testing and training. So to split the test and train data, we can use this sklearn model selection train test split function. After this, we can do this by sending these parameters, that is the df has the data set and y is our target, which that's what we are dropped from this column, from this data set, and the test size is mentioned as 0.3. that is the remaining 70% is for the trained data and 30% is for the test data. After this is done, we are printing the xtrain.shape, that is the shape 149 and 9, which is one. I'll explain you this. See, totally the main dataset contains the 214 rows, and 149 rows are spent for the test data and not the train data, and that is what the train.shape, right? So we got the 149 rows for the train, and the remaining rows are for the test data. And after this, we have to do the machine learning classification. To do the machine learning classification for tree graph, for the tree classifiers, we need the pi.plus for classifying. So I'm just installing using the pip. After this is done, we are going for the ID3. This is the code for ID3 algorithm. In ID3 algorithm, we are just importing the tree decision tree classifier from the sklearn.tree to do the tree classification. We need that, and for calculating the accuracy score, we are importing the accuracy score from the sklearn matrix. After this is done, a clf.decision tree classifier, which is initialized using the criterion as entropy, as we need the entropy for the ID3 thing. So ID3 algorithm. So after it's initialized, we can use the clf.fit, but that is the model is trained by sending the x train, which contains all the chemical values, and y train, which contains all the predict, which we need to predict the things. So this is done, then the clf model is trained for it. When it's trained, we have to predict it by sending a parameter, that is clf dot predict, and sending the parameter, that is x test, which should be tested by using the chemicals. X test contains all the chemicals, the remaining rows where we have separated by using test split using the sklearn, right? So that is sent through this parameter, and after that is done, the y pred contains all the predicted y values, that is all the types of glass it contains. When it contains all things, now we are executing this, the accuracy score. to let's run this up, and we got the accuracy score as 66%. That's what we got using the ID3 algorithm. So when it's done, let's plot the graph for this, that's the tree for this ID3 algorithm. To plot the tree, we just have to import this externals.6 string IO and display the images for representing this image here, and the sklearn. Let's run this thing, sklearn.tree, and export graph base. So export graph is, and py.plus is for the tree thing. So to print the tree, let's store the tree as a graph something. So let's I'll explain about export graph base. Export graph base contains all the parameters that are required. This is CLF, out, f.data, and all this. CLF is the train model. We are trained using the ID3, and this is the dot data, and these are all the parameters. That is rounded is for the making the call boxes as rounded format, and all these are feature names which contains all the chemical names in that. With df we remove the last target variable, right, the target attribute, so it contains only the chemicals. So the next so these are the feature names for that. Then after this, the special characters are mentioned as true, then it can use the special characters in that. So we're using the py.plus and storing the graph in graph variable named as graph variable, and we are outputting the image as PNG format, and graph.create PNG function by using this function. So this is the graph we got using the ID3 algorithm. After this, we are doing the cart algorithm. For the cart algorithm, we are importing the decision tree classifier and the sklearn matrix and mean squared error for calculating the mean squared error for the cart. So first we are initializing the decision tree classifier. After this, we are fitting, that is the training thing is done by sending the X train and Y train to the model, and it is trained as CLF. When CLF is done, the Y pred is predicted, the Y the same thing, the CLF dot predict, and X test is sent to that, and it checks the predicted column, that is the type of class by prediction comes in this. So as it can be calculated here, then ASC, that the accuracy score, then by test and prediction are compared here, and it checks the accuracy score in this. Our accuracy score is 72%. That's good. And after that, we're calculating the mean squared error, which are imported using the sklearn.matrix. After this, the RMSE is calculated by square rooting the MSE, that is the mean squared error. So after this is done, then printing the what is the accuracy score and the square mean squared error and the RMSE. So these are all what we got the results. After this cut, then we have to print the tree by using this same the code we use here is almost the same. We're using the sklearn external string IO, MAs, and export graph base and py.plus, and the same thing is done over here. And the model is which is sent is here from here, the CLF, and it's all calculated here and creates the graph for here in a PNG format. I already explained the code about that, and this is the graph that is done. Let's execute it and it will create the graph. And after this is done, when the graph is created, I'll explain you the thing. Yeah, so this is the graph created, and this is how it came, the card thing, the card graph for this. And after this, the df.fill NA is used for any and like NaN data points are left, like which are empty or not filled. These can be just neglected by using this command. Replaces them with the mean value, or we can use 0 in place of this to mention them as 0. So where it does all the NaN, it converts all the NaN to anything like zeros and mean. Here it converts to mean. After that it's done. This is the code for perceptron, for the single perceptron to run. We are using the sklearn.datasets and load digits. We are loading the digits, and after this the perceptron is imported by using the sklearn linear model from the sklearn. Then the perceptron the variables are set in this at random status 0 and EOL are IE -3. Then we are fitting this model, that is the training this model by using the X train and Y train, the same thing. And after this we are testing the score for this by using the X test and Y test. We are just sending this model to the X test and Y test. It directly predicts and gives a score for this, which we don't require any accuracy score or anything, which directly shows this in this perceptron. So this is what we got, the 50% for the perceptron. So let's go for the neural networks, which contains multiple perceptrons in this, so we get a better score in this. For the neural networks, we are just importing we are same thing, like we are taking the neural networks from the sklearn using the MLP classifier, and we are sending the parameters as solver LBFGs and alpha, and hidden layers are left as 5,2 and random state is 1. So the classifier is trained by using the X-train and Y-train. X-train contains all the chemicals and Y-train is the main thing we have to predict, and when it's executed it gives this output, and after this the Y prediction, the classifier dot predict, now it's predict, then the model is trained for this, that neural network is built for this, then we are predicting using the X test, then we're storing those values in YPred. So let's create a confusion matrix and the classification report for this. So this is what we get, this F1 score for this, and the precision we get in this, and these are the values we get by using the neural network. This is the neural network code for this. Okay, after this what we are left with, the logistic regression and the random forest. For the logistic regression, we are importing this by using this sklearn. From sklearn.datasets we are importing the load iris and the linear model, and from linear model using just importing the logistic regression. We just need the linear model for this, so that's why we are putting the linear model. Then the logistic regression, we are using the CLF, and we are initializing it with the random state and solver IBFG, then multi-class as multinomial, and we are directly feeding here itself, that is the dot fit, X train and Y train. Now this model is trained for the logistic, and when it's done, the model is created as CLF. We are testing the score with CLF.score, X test and Y test. When it's the score, his predictor is 53%. That's what we get for the logistic regression. After this is done, we are creating for the searching for the random forest. In random forest, we are importing this from sklearn. From the sklearn ensemble, importing the random forest classifier, and the matrix of the mean squared error and the square root is for RMSE calculation. So let's go for the random forest classifier. The random forest classifier is initialized here, where the n number of estimators are set as 150, and the maximum depth of the tree, the random forest creates multiple trees as single, right? So it keeps on updating the trees, so those creates a new trees on changing those randomly. So that is kept as a maximum depth of 3 and the random state as 0. So let's train this by using the CLF.fit, and the X train is sent and Y train is for the prediction thing, and when it's done, let's predict this, the model, using this model, the X test is sent as a parameter here, then the YPred is calculated, then YPred is calculated, we can calculate the accuracy score which we have imported earlier, that is the accuracy score equals to Y test and YPred. It checks whether the Y prediction is equals to Y test and calculates the accuracy score. This is what the accuracy score we got, that is the 6.0692, and after this the accuracy score is done, the MSE, the mean squared error, is calculated, which is imported from the sklearn.matrix. This can be calculated by using the Y test and YPred as the parameters. After this is done, the RMSE, that is the square root of the mean squared error, so we can directly use the SQRT of MSE to calculate the RMSE. We are printing this RMSE also, that's what we got as 1.08. This is the random forest code for this, and for the glass classification. After this is done, the KNN and all these can be calculated. We are done only. So this is the end of the code. So thank you for watching the video. Hope you like the video. Thanks.